So we did an island biogeography simulation lab where we threw craft sticks at different sizes of islands, and we've collected the class data for this. So make sure that you have already collected the data and you've watched that video. And now we're going to use that data to do some analyses. We're going to use it to calculate species area curves for these islands. We're also going to generate the immigration rate curves and the extinction rate curves, the local extinction rate curves for these islands, and use those lines, those curves, to come up with an equilibrium number of species predicted for each size of island. So since we're looking at species area curves, I've already got a video recorded, a video lecture recorded for that. And I've also got one already recorded for island biogeography theory. So you should watch those as well before doing this. I'm Sue Glenn. This is for my ecology classes. And we use the Ecology Lab Kits Island Biogeography Lab to collect the data. So our first stop in using this data is to generate a species area curve for the number of species on different sizes of islands. I do have a complete lecture on that you should watch before doing this, so you may want to stop here and go watch that. I went over these graphs in the other video on species area curves, and as you can see, we've got on the y-axis on both of these, the dependent variable is the number of species. So the graph on the left are the number of bird species, and the one on the right are the number of beetle species found on different sizes of islands. And the island area is on the x-axis, it's the independent variable, and we can see both of these axes have a log scale on them, so that the log scale is actually straightening out these into more of a straight line. It's pulling down the big values, so you can see the variation in the data a lot easier. If we didn't have the log scales, it would look like this graph at the top, where we have the area on a normal numeric scale on the x-axis and the number of species on the numeric scale on the y-axis, and we can see that kind of increases, but it starts to level off as you start to basically get all the species in an area. But then when we take that same data and we put those both on, we've logged the area and logged the number of species, you get a nice, much cleaner straight line there. The equation for this line is the number of species equals a constant c times the area raised to a power z, and that's going to be quite similar for different islands. The c tends to vary with the different types of species, and so the c tends to vary with the species, but similar islands have similar slopes basically. That z or z is the same as the slope of this line when you log both of those. So we submitted all of our data from your island biogeography islands into a form. And on that form, I asked you for the the average number of species you had on the island for the last 5 years, the last 5 rounds of your lab. And so we have that number of species, and we have your island sizes, so we can use that to generate a species area curve. So what you need to do is go and copy that class data and make yourself an Excel workbook, and then make a sheet that you're going to use for generating a species area curve on that. So I'm going to show you an example. I don't have the whole class data yet, so I've made up a data set that I'll use to show you what I mean. We input our island biogeography data into a Google form, which had a grid box, and we checked off which species were in each row. So it comes off with a data set that is in a very strange format. This is just a sample data set. This is not the class data, but you would download the class data. And where it has name on here, you would have the name of each person and then the three island sizes that they used, and then each column is a separate year. So instead of having the little checks in the boxes, it records this with the names of the species, like orange long, yellow long, blue small, orange long, purple long, red long. So it's got the actual species that you had entered in there. And then I'd also asked you for the average number of species in the last 5 years. So you just take the last 5 years, add them up, and divide by 5, and you get the average number of species. So this average number of species is what we're going to use to do a species area curve, and we're going to need the actual island sizes. So I made an extra sheet called species area curve. If you don't know how to make a sheet, you're in the form responses, you just push the little plus sign and a new sheet will be created, and then you can give it a name, whatever you want to call it. You can, and then you've got an extra sheet put on here. You can even give it different colors for your different sheets if that's what you want to do, so you can find them again. So I already have one here, so I'm going to delete this because I don't need that one. And I have one that I called species area curve. And I set it up with the different sizes of islands that everybody was trying out, and then the average of the last 5 years. And if I go to these responses, I can see that for the island that I did that was 6,400 square centimeters, I got 6 species. So I can go ahead and I can just put that 6 species. It was 6.0 species. If I want to put a decimal point on each of these, I just have to shift my decimal points over. Oh, it's not going to let me. Let me see. There we go. Now it is. I can do that for the whole column. Have to put more data in. Okay, so I've got one of these on here. I can find another one. So I've got 4,900 square centimeters and 1,600 square centimeters. And I got the data 4 and 4.4. So 4,900 was 4. And I've now forgotten what the other one was. 4.4 was for 1,600. 4.4. Now that's only 3 points. That's not going to be enough data. So what I want you to do is to find other people's data sets where they've done different islands. And you want to get at least 2 islands for each area. So I can just take this, I can copy that, paste it there. And that way I can find, and they don't have to be in order, but I can find other data sets that had put in their averages as well. So you get at least 2 of each one. And I've done that here. I made a species area curve where I did that. So I'm just going to take the data that I got here, and I'm going to pop it in here and use it over here. So that was the average of the last 5 years. So now I have the area that we're going to need as our independent variable on the x-axis, and I have the average of the last 5 years, which I'm going to put onto my dependent variable. I'm going to simply insert a scatter plot. Da, da, da. And so we can see with this data, we've got the number of species starting to level off here. And then I need to add on some axes titles. So I have across here, area in centimeters squared. I can even take my square here and make that a superscript. And my axis title of my y-axis is average number of species. Now, I want to get the species area curve. I want to get the equation of that line. So I'm just going to go to the dots and I'm going to right click them, and there's an option to add a trend line. So I'm going to add a trend line, and it put a linear line, but we know that this is a curved line. This is actually a power function. So I'm going to click that, and now I've got the power function, and then I want the equation. And so remember we had that equation where area equals, or sorry, the number of species equals a constant C. So we can see the constant here in this case is 0.0095, and that is times the area, because our x-axis is area, raised to an exponent, that's z or z exponent, which is 0.7531 in this case. So for this example, we have the exponent. Now, I also showed you on the previous slides you could do log area and log number of species to get a straight line. I did this in my other example. Where's my species area curve? Right here. So this is the one we just did, but also I put in a column where I did the log of the area, and I did the log of the average, and generated a straight line. And when I generated the straight line, you can see that the slope of that straight line is exactly the same. So the slope of the straight line right there is exactly the same as the exponent up there on the power function. So the exponents are the same. And then this constant is actually based on the intercept. We can see that if I take the intercept, put 10 to the power of the intercept, I get that constant up there. So there's two ways to generate the equation for these lines. So that's how you get your species area curve. We're going to move on next. We're going to talk about the immigration and extinction curves. At this point, you may want to stop and watch the video on island biogeography theory so you understand the theory behind these immigration and extinction curves. With immigration, we're talking about immigration of species onto an island, and the extinction we'll be talking about is local extinction of species that are already living on the island. And both of these are, in the theory, are related to the number of species already living on the island. So we're going to show you how to set up the data set in the right format in order to generate these curves. So there's several steps involved. So go ahead, stop here, watch the island biogeography theory video, and then come back and pick up from this point. So as you know, you put your data into a Google form, and we ended up with that very strange data format. And what we want to do is we want to get it back into the format that your original data sheet was in, where you had the years being the different rows, and then the species were your different columns. So we want it to look like this data set here, where we have the years being the rows and the species being the columns. So we've got to get out of this format and put it into that format. And that is going to take us a couple of steps to do. We're going to, the very first step then is going to be taking years, which right now are different columns, and we're going to make those as different rows. So that's first transposing the data set. So you have a copy of the class data, you're going to make a new sheet. And then in order to get these different columns to become different rows on that new sheet, we're basically going to copy the rows. So we're going to copy the data set that you want from the Google sheet, and then we're going to paste it into a new sheet where we will transpose it. So we'll use the function, the paste transpose function, and that'll make each column a separate row. And then what we had in the columns will, or in the rows, will become columns themselves. It's still not perfect. We still got all these little names in here. That'll be another step. But I'm going to show you how to like paste transpose this to start with. So this is the weird data set that we got out of Google Forms. And so I've downloaded, I have the data set so I can use it in my own spreadsheet and edit it. Then I made a separate sheet that I'm going to transpose the data in. And you can call this anything you want. You could call it transpose data, whatever. You can leave it sheet number 2, whatever you want it to be called. And then I'm just going to take the data, right click, copy. Then I'm going to my new sheet, and all I need to do is right click, and you can see there's this little transpose button here. So instead of pasting um, values or formulas, I can paste transpose, and that's just flipped it so that what was columns were rows and what were rows were columns. So I can transpose the data and it's right there, easy. I can clean it up. I can take off this top row. I actually want to clear the contents of that. I'm going to use this top row so that I've got, and if you want to clean it up a little bit, you can make the columns bigger or smaller. This one seems to be wrapped. I'm going to unwrap that column. And I've got these comments and these average numbers down here. I don't need to worry about those anymore. I can take those off if I want to, however you want. So now you've got your transposed data set. So your data set looks like this now, where you've got the years now are as in rows, which is what we're aiming for. We wanted the years to be in rows, and we've got each year in a separate row. So you use the copy, paste, transpose, and we got that step down. Now we've got to get all these little individual species to be made into different columns. Now, I know this seems like a lot of work, but you can imagine if you have a lot of big data sets that you've already entered into a form and you need to put it in a different format, it's good to learn how to do that instead of having to re-enter the data. Not only does that in the long term save you time, but also reduces errors because you have errors that go into data entry and you want to minimize the number of times you're retyping things. Also, the advantage that we have here is we get to learn a few more Excel functions. And so it takes a little while to figure out what functions Excel has. It's got tons of different things it can do. And so we're going to be using a few functions. We're going to be using for the search function. So we're going to be searching the data set to find each individual species. So I might be looking for what years have the red long species, and I'm going to use a search for that. Um, if it finds a species that I'm looking for with that search function, it tells me where in the cell that is, like how many spaces across in the cell you find that. So it'll return a number. And so if it turns a number, we're going to use ISNUMBER. Is it there? Is it returning a number to me? And I just want to make those into ones and zeros. So then the last function you're going to be learning, and you probably already know this in Excel, is if. So if it returns a number, then put into my data set a 1, and if it doesn't return a number, put a 0. So we're going to do the if 1. So we're putting all these things together into basically a function where we have the search, the ISNUMBER, and the if all together. So let me show you how to do that, and it's going to transform our data set from all these little species names to making a separate column for each species. So the first thing you want to do is set up the data set the way you want it to look with all of those individual columns. Make a sheet that looks like this one here. So what you're going to do is you're going to put, I have, you notice I have started in row 2 because I'm actually going to use row 1 for something. I've started in row 2 and I have the years of the species listed across here. So I just typed in the name of each species because we had 12 different species, and then I made a column for years. So this is like a data sheet just like the one that you have in your lab book. Should look exactly the same. So make a new sheet. So you've already got the class data downloaded. You've already transformed it into this format. Now make a separate sheet and a new tab and put the species across as separate columns and the years down the side as your separate rows. Okay, so we downloaded the class data. We have copied that class data and transposed it into this format. So I have that sheet called copy transpose. And now I am going to work on this column here, which is the island that was 4,900. So it was 70 by 70 centimeters in size, so 4,900 square centimeters. And so I made another sheet called data table 4,900 for that data set. So I have my years in column A, and across I've got row 2 here that I'm working across. I have each of my species listed: red long, orange long, yellow long, all the way over here to purple small. And so what I'm going to be doing is I'm going to be using this function that is typed over here in order to pull in information from this file called copy transpose. And so you can see in this formula here, I have the data set copy transpose listed. So I'm just going to take this one piece at a time. And the very first piece I'm going to pull out of here is this search function. Control C, copy that, put that there. So I type equals search, and what I'm going to be doing is I'm going to be finding the text that we have in cell B2. So that's red long. And then I'm going to look for that in our data set that is in copy transpose. And when I'm looking for that in that data set, I want to look in column C in copy transpose because that's where my data for the 4,900 one is. So I can go over here, look at copy transpose. It's going to be in column C. So I'm searching for what's in B2, and I'm going to search in column C, starting with number 3. So copy transpose C, starting with 3, starting with that cell. And for each year, I will want to be looking down at other cells. So I've put I always want to be in column C, so I have the $ in front of column C. And I always want to be looking for the species names from row 2 here. So I've got a $ in front of the 2. So I'm searching in copy transpose in column C for what I have listed here in row 2. So that's this part of that. Now I've got ISNUMBER. So right now it tells me that in copy transpose in row 1 in spot number 1 I have red long RL. So I have that sitting there. But if it was in a different location, so if the RL, let me just move it here. If the RL was listed as the second species, if I go back here to my data table, now it's listed as a 5. I just want a data set of zeros and ones. So in order to make that into a 0 and 1, I have to first of all say, is there a number? So I'm going to use the function isNumber. And just see whatever I got out of that search function is a number. what is it told me right here? True. So I'm going to get true or false. So now I want to change trues to ones and falses to zeros. So I'm going to put equals if, and whatever that is giving me, close the brackets there. Not close the brackets there. If it's true, I want a 1. And if it's not true, if it's false, I want a 0. And then close that. Sorry for the alarms in the background. And so hit enter, and now I have a 1. So now if I drag this down, I should get that for every species, or so for every year, is going, so here it was looking in row 3, but here it goes and it looks in row 4, which if we look in copy transpose, row 4 is year 2. And then I can do the same thing. I can take this and drag it all the way across. And so now this should look exactly like the data table out of your lab book. We've got ones for we saw the species and zeros for the years where we didn't see the species. So you've now used the search function to find the species. So let's say if I look over here in column C, I am searching for what is in C2, which is orange long. And then I'm looking back over to my transpose data file in column 3 to see if I can find that in row 1. Or sorry, it's actually column 3. Right over here. Column 3, row 3. Or column C, row 3. That's it. Column C, row 3. So we've got the C3. So anywhere you look on here is just changing where you're looking on the transpose data set and also changing which species you're looking for in the top row. So now you know how to convert from this text file over here into our numeric file. I just wanted to point out that when you are doing this conversion from the original or from your transposed file into this new table, and you have that if ISNUMBER search statement, that the name of the file, my sheet was called copy transpose, and so you would want that to be whatever you had named your transposed sheet. And then where you're searching for your first species is going to depend on how you set the table up on that sheet. So I was searching for my species name in row 2 in column B. So if I look here, I'm in row 2 in column B. I've got the B2 here. And don't forget the $sign so that you're always staying in row 2 to look for species. And when I'm looking for what data set in my transpose file I'm going to be using, remember I've got to have the right name for that sheet, and then the B3 is where I'm starting to look for the data. And in this particular example, I was taking it from column B, row 3, but the example I just showed you, I was taking it from column C, row 3. So it just depends on what data set you are looking at, which row. So you can transpose and copy the entire class data set. You can have a row for everything single student and get a table like this generated very, very quickly and easily. Now we've got the table, we're going to have to figure out what the immigration and extinction is from year to year. And you could go through here and you could sort of copy down, well, I had from year 1 to year 2, this was an extinction and this was an immigration. You could do that by hand. I'm going to show you a much faster, easier way to do that in Excel. So we're going to be adding in 3 columns to your data set. Remember, I started my data set in row 2. And so I'm putting here just to specify, so this is past the end of the data set. I have beginning of round. the number of species. So this was number of species who were on the island before I started throwing things on the island. So it's the number of species in the row above. So put these words as the title here, and you're going to make a column for the immigration rate, which would be species per year, and the extinction rate, which is going to be in species per year. And then I'm going to show you how to fill in all of this so you don't have to actually sit there and count it. I've added the extra columns here, and so if we start in year 1, the number of species that was already on the island before you started throwing sticks on the island was 0. It was an empty island, so that's easy to fill in year 1. And then anything that landed on that island that didn't get washed away in the water under something else would be your immigration rate, and that's going to equal the sum of what we had that year. So that's why we wanted ones in this table. We add those all up, and we had 2 immigrants, and nothing was on the island to start with, so nothing could go extinct. So the first year is easy. Now, the second year, we have now, before we started throwing sticks, we had 2 species on that island. So in order to get the initial number of species before you start throwing the sticks, you need to add up how many were in the year before. So that's just going to be a sum function. So equals sum, open bracket, and then I'm just highlighting the year before. So I'm in row 4 now, but I'm adding up how many species were there added in the row above, row 3. So I close my parentheses, and so there were the 2 species. So all I need to do now is going to add up every row is going to add up the row above it. So I can just take that and I can copy it all the way down here. And so if I wanted to check that, let's see here on row 14, I should be adding up the ones the row before. 1, 2, 3, 4, 5, 6. And so there were 6 the row before. So that works just fine. Now, we're going to do a summation for the immigration rate as well, but we're going to add some criteria to that. We're not going to add up all the species that are there in the next year unless they were missing the year before. So we have 2 criteria. One is that the species is present to add it, but second, it had to be a 0 the year before. So we're going to use this function called SUMIF. So we're going to do SUMIF, and we're going to put S on the end. There's SUMIFS because we have 2 criteria. It's there now, and it wasn't there before. So what are we going to be adding up? So our sum range is going to be things that are in that year. My first criteria, I'm going to look once again at that same range, but the criteria is it has to have a 1. It has to be there now. And then I'm going to add another criteria, my criteria range 2. I'm going to look at the year before, and it had to be absent. So it had to be that my criteria is a 0. So I'm summing from B4 to M4, so over all the 12 species. And I'm going to look at those 12 species, and I'm going to only add them if they're there now, but they were absent the year before, which is in row 3. Close that and hit enter. And so if we look here, this is a new species, and this is a new species that weren't there before. So I had 2 immigrants. Now I can do the same thing with extinction rate. I can say add up species in this area. Oh, sorry, species that were there the year before. Add up the species that were there before. And, oops, it's not just a sum, it's a SUMIFS, right? SUMIFS. They were there before. And so the year before, they had to be present. So in that range, they had to have a 1. But then this year, they went extinct. So in this range, they have a 0. And hit enter. And I had 2 extinctions. And if I look here, red long went extinct and red short went extinct. So I had 2 extinctions. So now I can automatically generate that instead of going through and seeing what went extinct and what didn't, which is how we used to do this. We just use the SUMIFS and we can go all the way down like that. So now I have the immigration rate and the extinction rate for every year on that island. And I had the number of species that were already existing on the island to get those rates. This is the data set for the larger island. I did the 6,400 centimeter square island. We've been working on the slightly smaller one, the 4,900 centimeter square island, but I used the same process. So we used the sum function in order to add up the number of species the year before so that you could put that as the initial number for throwing the sticks the next year. And then I also used the SUMIFS to give the total of the criteria I set. So for immigration, the SUMIFS are where that it has to be in this particular year, but it could not have been in there the year before. So there were 3 of those. And then the SUMIFS for the extinction rates had to be there the year before, but not in the next year. So 1, 2, 3, 4 of those were missing the next year. So now we're going to just take the data over here and we're going to use the number of species that we start with on the island. And then we're going to look at the immigration rate as a dependent variable and the extinction rate as a dependent variable to do a scatter plot. And then we can do the trend lines for these guys and get the equations of those lines. So I'm back in my data table for the 4,900 square centimeter island. And I am just going to highlight the information, including the column headings for the data that I'm going to make a scatter plot. So I'm going to go Insert, Scatter Plot, and here we go. And then I'm just going to move this down. And if I click on one of the data series and right click, I can add a trend line here, and this is the immigration data. And if I click on the extinction data, right click, add a trend line onto the extinction data. So I have the immigration rate, the immigration data is in blue, and I can put on the right here, I can put display the equation on the chart. So I have the equation here. It's almost flat. So that's my immigration data. So I'm actually going to make that equation blue so that you know it goes with the blue line. And then I'm going to click on my extinction line, trend line options, and go down here and I'm put that equation, move it down over here, and I'm going to make that one red in color. So it goes with its line as well. So now I have the equation for immigration. I have the equation for extinction. I need to add my axis titles. So across here, this was my species richness. Or you could say your number of species. Which in this we've been calling N. And then on the y-axis, I've been putting the immigration and extinction rates. And they are in the units of species per year. Just going to make this a little bit smaller, make my graph a little bit bigger. so you can see everything clearly. I can zoom in a little bit to that, take out my format chart, and zoom in a little more. I'm going to put my chart title as my island size. Now, something that you should notice here is that these lines cross. And this is for my 4,900 square centimeter island. And my lines have crossed so that we've got a point where they cross where the immigration rate and the extinction rate are equal. And where immigration rates and extinction rates are equal, they're balancing each other out. And that is your equilibrium number of species. So the equilibrium number of species is going to be somewhere just over 3.5 species on this particular island. This is made up data, by the way. And so since I know where these lines cross, that the y value is going to be the same, it means this equation is equal to that equation. And then I can solve for n, for the equilibrium, for x, which would be my number of species at equilibrium. So which is normally shown with an n star. So I can actually find out the equilibrium number of species by rearranging these equations to solve for x. So I'll show you how to do that next. I did that over here for my 6,400 centimeter square island. I have the two equations, and over here I've solved for x. I'll show you that. So we know where the lines cross, that is where the equilibrium number of species is going to be determined when immigration rates and extinction rates are equal. This is the data for my island that was 6,400 square centimeters, and you can see my lines cross on the graph so that I can calculate where they cross is where those two equations or those two lines are equal for the y values. So if I have my equation for immigration over here and I have my equation for extinction over there, we know they have the same x and y values where they cross. So if I have them equal, I can solve for the x value, which will be the equilibrium number of species, and it's on both sides. So I want that to be on one side. So I'm going to take what I've got over here, and I'm going to move it over to that side, and I'm going to take what I've got over here, move it over onto that side. So I have the 0.5866 plus the, I was subtracting this from there and there, so I had to add it to both sides. So I've got n is 0.5866 plus 2123, so those are straight out of those equations, the 2123 and the 5866. And then when I put the intercept values on the other side, they're over here, 4.3 plus 0.6. And then in order to isolate the n star, I'm just going to divide both sides by what's in this bracket. So I have that divided by that. And I end up with an equilibrium number of species of 6.18. So when we look back on our graph, the equilibrium of species is just over here, just a little over to the side from the 6. So that makes sense that our n star is over there. And we can also, remember, we still got species coming in and species going extinct, so we can determine the species turnover. The species turnover is the number of immigrants and the number of extinctions at equilibrium, which is the same. So it's 2 times whatever one of those. So I can just take my immigration equation up here, and I substitute in for the x, I'm going to substitute in this equilibrium number. So the 6.18 is my equilibrium number, and I solve that, and then I double it. So for the extinctions and for the immigrants, and I end up that species turnover is 6.02. So there's approximately 3 new species. If we look over here where these lines cross, there's approximately 3 new species coming in every year and 3 local extinctions every year. So this is for the 6,400 square centimeter data set. I'll do the same thing on the next slide for the one I just did on the Excel spreadsheet, which was the 4,900 square centimeters island. This is the data from the 4,900 square centimeter island, and so we can go ahead and figure out where those lines cross, and that will show us what the equilibrium number of species is exactly at that point. So we know that where they cross is these two equations are equal to each other. So I have the equation for the immigration is 0.0568 times the number of species, plus 3.0773 equals my equation for extinction, which is 0.7045 times the number of species plus 0.7182. And so we're going to have to solve them for n. So we want to get n isolated on one side. So I'm going to subtract this n from each side. So and then I'm going to subtract the 0.7182. So I'm going to have 3.0773 minus 0.7182. And then this will be 0.7045 minus 0.0568 times n. So all I did was I pulled that over there, and I pulled that over there on each side of the equation. So when I subtract those out, I'm going to get 3.0773 minus 0.7182. That's going to be let me get a better color than that. It's going to be 2.3591 equals, I subtract 0.7045 minus 0.0568. That's going to be 6477 times n. It's still times n. So I still need to isolate the n, so I got to divide both sides by that 0.6477. So 2.3591 divided by 6.477 is 3.64 equals my equilibrium number, which makes sense because when we look on the graph, that would be right. That's where they cross. So that's my equilibrium number of species. At equilibrium, we know there's still species that are there's still approximately 3 species immigrating and 3 species going extinct at that point. Immigration, remember, immigration equals extinction rates at that. And so we have species turnover. And species turnover, I can solve for the immigration rate, and when I solve for the immigration rate, I just double it because it's the same as the extinction rate to get species turnover. So if I plug in my equilibrium number of species into my immigration equation, I'm going to get, my extinctions are going to be 0.0568 times 3.64, which is my equilibrium number of species, plus 3.0773, and I work that out, and I get 3.28 immigrants. And the number of extinctions is going to be the same, so we're just going to multiply that by 2, and we get around 6.6 species changing, and that is your species turnover. So 3.3 approximately of that are new immigrants, and 3.3 are local extinctions. So now we have our species turnover on this particular island, and we also have figured out our equilibrium number of species on the island just by doing some easy algebra. So that was a lot of Excel you used. You learned how to transpose rows and columns. We've done that before. We've used scatterplots before and put on trend lines. I used the power function for some of the trend lines, and we use the equations that we got for the trend lines to algebraically solve for where the lines crossed. You use the search function, the ISNUMBER function, the if function, the sum function, and the SUMIFS functions in Excel. So that's a lot of Excel you've got. You may want to go over some of these and make sure that you understand that you're getting the information from the right cells in the spreadsheets. But other than that, you've got quite a bit of Excel under your belt now. And so there's some really good Excel videos on YouTube. I'll add some links here and also the links to the island biogeography presentation and the one on species area curves in case you didn't go back and look at those. And this is a beautiful picture of some of the few of the 7,100 Polynesian islands. So I hope you enjoy.